This is the University of Hawaii Maui College, the college on Maui.
But before we start with the math, we're going to take a step backwards and talk about some things that everyone thinks that you already know everything about. So the first thing I wanted to show you is this, my friends, is 1 meter long. Here, there it is sideways. Yeah, see, we have help in the back. This is 1 meter. This length right here is 1 meter. And we're going to talk more about that. This right here is a 1 liter bottle of water. And this 1 liter bottle of water, the water in this bottle weighs 1 kilogram. And that's what we're going to talk about today. And so this is 1 liter of fluid. And this little syringe right here, I'll show you this later, this holds 1 milliliter of water. And that's going to be my topic for at least the next few minutes. And so you can have that right there if you'd like. When you're at the store, grab a 1 liter bottle and feel that, and notice that it weighs 1 kilogram. So we'll move over the PowerPoint slides, make sure I brought them with me today. And we're going to try to take all this jumbled confusion mess that we have on our hands and try to make some kind of sense out of the metric system. And so I showed you the 1 liter bottle of water. 1 liter of water weighs 1 kilogram. And this is where the metric system begins. And so when you're at the store, whatever you're shopping for, if you see me in the fluids section, I'm usually looking at the fluids, doing the conversions. Notice that this bottle says it has 1 liter, which is the same thing as 33.8 fluid ounces. I wouldn't worry about that. But a liter is about 1 quart, 1.06 quarts. So fortunately, if you know what a quart is, you know just about what a liter is. And again, 1 liter of water weighs 1 kilogram. Well, here is 1 milliliter of water. Here, I'll switch the Elmo so you can see what this looks like. This is a 3 milliliter syringe. And if I draw my imaginary water into this syringe, right there, I have exactly 1 milliliter. See? A little teeny tiny thing. So a milliliter is the same thing as a cubic centimeter. Volume and length are related to each other, and we're going to show you that. But right off the board, I wanted you to know that 1 milliliter of water is the same thing as 1 cubic centimeter, and a milliliter of water weighs 1 gram. And if you took 1,000 of these little milliliters, if you did that 1,000 times, then you would end up with 1 liter of water. I have a little ruler I got at the store. It's about this long, about a foot, about 30 centimeters. And so I wanted you to take a look at the ruler when you're in the store. Fortunately, we have one floating around the classroom. For those of you who are interested here, you can have that one too. And you'll notice I can see 10 centimeters on there. We blow it up. That's 1 centimeter. 1 centimeter is 1/100th of a meter. And for those of you who actually have the vision, you'll notice that that is 1 milliliter. I'm sorry, 1 millimeter. And 1 millimeter is 1,000th of the meter that I showed you at the beginning. So this is about measurement. And what the metric system is about is this right here. Corresponding lengths with volumes with weights because they are related to each other. The system that we use, it has all sorts of names. We call it the American system. The lengths and the volumes and the weights, they don't really have anything to do with each other. But the beautiful thing about the metric system is lengths and volumes and weights are all very carefully related to each other. So we can go from milliliters to cubic centimeters without calculus. So these are the fundamental units of the metric system. Length is measured in meters, and a meter is just about 3 feet long, and I showed you that at the beginning. Volume is measured in liters, and weight is measured in grams. Now, I know some of you are worried about the difference between mass and weight, but everyone here lives on planet Earth, so we'll talk about the difference between mass and weight later. Weight is measured in grams. And so this is important that you understand the fundamental units of the metric system. All right, so the word kilo means 1,000. So kilo anything is 1,000 of them. So a kilometer, a kilometer, is 1,000 meters. And so I showed you what 1 meter looks like, about 3 feet. And so a kilometer is about 6/10 of a mile. I don't need you to know that a kilometer is 6/10 of a mile. I need you to know that kilo means 1,000. And that's what's important here. So a kilogram is 1,000 grams. A kilogram is 2.2 pounds, thereabouts, and that is something that you will need to commit to memory forever if you're going to be in the healthcare business. And so today is a great day to start with that. 1 kilogram weighs 2.2 pounds. 1 kilogram weighs 2.2 pounds. There are 2.2 pounds per kilogram. 1 kilogram per 2.2 pounds. Okay? Kilo equals 1,000. Kilo anything is 1,000 anything. Centa means 1/100th of. A centimeter, which we talk about all the time, is 1/100th of a meter. And that's abbreviated. 1 centimeter is equal to 1/100th of a meter. So you notice the abbreviations there. They're about 2.2 centimeters per inch. And I don't really need you to know that, but those of you keeping score, doing the rocket science in this class, you need to know that 2.2 centimeters is equal to an inch. Milli means 1/1000th of anything. So a millimeter is 1/1000th of a meter, and I showed you the millimeter earlier. And abbreviated, that's mm. 1 mm is equal to 1/1000th of a meter. A milliliter is 1/1000th of a liter. I showed you the 1 liter bottle, and if we divided that into 1,000 parts, we'd end up with a milliliter. And you can see the abbreviation down below. Sometimes liter is abbreviated with a big L. Sometimes it's abbreviated with a little l. Sometimes liter is abbreviated with a cursive L. And sometimes you'll see liter spelled L-I-T-R-E. That's the European spelling. We have to be backwards here and even spell the metric system differently. A milligram, which we talk about all the time in pharmacology, is 1/1000th of a gram. And remember, a gram of water is 1 milliliter. So 1,000th of that is a milligram. And so 1 milligram is 1/1000th of a gram. And so when we talk about 10 and 20 milligram doses, you can see how teeny, 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 tiny amount that is. Micro, we might actually talk about micro things in here. I think we talk about micrograms. Micro is 1/1,000,000th. A microliter is 1/1,000,000th of a liter. And so we see 1 microliter is 1/1,000,000th of a liter, but if you think about it, 1 microliter is 1/1000th of a milliliter. And that's actually important information. But I think this is more important right here. A microgram. We talk about micrograms all the time in pharmacology. A microgram is 1/1,000,000th of a gram. And so a microgram is 1/1,000,000th of a gram. But something that you will need to know in the healthcare business forever is 1 microgram is equal to 1/1000th of a milligram. And notice that they're kind of spelled alike. Sometimes instead of using MC, they'll use the Greek letter mu. In this class, we'll spell it just like this. A microgram is equal to 1/1000th of a milligram because a microgram is 1/1,000,000th of a gram. And so hopefully moving those decimal points around by 3 places is something that you're going to be able to do in here. All right, so because everyone here that's taking this course does live on planet Earth, I have been assured of that, Mass has weight because of gravity. And so that 1 liter bottle of water weighs one kilogram here on Earth. However, if we took it somewhere else, like the moon, it wouldn't weigh 1 kilogram. It would weigh much less. If we took it to Jupiter, I think it would weigh 100 kilograms or so. I'll be sure and research all that next time I give this lecture. However, the mass of 1 kilogram remains the same. And so for those of us in outer space or on other planets, weight is a function of mass, and you can take physics to do all those calculations. But for those of us on planet Earth, weight and mass are the same thing. Okay? Just wanted to make that point and belabor it. Remember talking about this. The fundamental units of the metric system. Length is measured in meters. Volume is measured in liters. And weight is measured in grams. And so volume is a function of length. And weight is a function of a volume of water. And so from length, we can make volume. And from volume of water, we can make weight or mass. So what I want you to know is all the most important conversions within the metric system are based on multiples of 1,000. A kilogram is 1,000 grams. A milligram is 1/1000th of a gram. A microgram is 1/1,000,000th of a gram. But more importantly, a microgram is 1/1000th of a milligram. The centimeter, 1/100th of a meter. It's really the only place we use centa for is for centimeters. But everything else that's important in the metric system is really based on multiples of 1,000. And once you understand that, then you'll understand where engineering nomenclature comes from. But enough about that. So here's a line, all right? We've lost somebody already. This is a line. Everybody on board? All right. Cool. All right, everyone's back. This is a line, all right? And when the line can be measured, and I wish it was 10 centimeters long because that's what it's supposed to be, all right? And so we can measure with our little rulers that I sent you guys the length of a line, all right? And the length of this line can be any number x. I'm going to say it's 10 eventually, but it can be any number x. Any number you imagine can be x. Well, if we take another line that's perpendicular, 90-degree angle to that line, and if it has the same length, x, which is important, we have length times length. And now what do we have? We have length squared, all right? And that's exactly what this is, a square. And this tells us the area of something. So now we have area measured by length times length, or you'll hear it length squared. All right? So when you hear square, centimeters, square, meters, square, millimeters, all that business, they're talking about an area, because area is a length times a length. And this gives us a two-dimensional something. And where did it go? I lost it. Oh, well. Oh, there it is. This is my little 10 by 10 centimeter square. All right, so area is a function of length. Square area is equal to the length squared. This makes sense if you have a square and you measure one side and the other side, multiply them times each other, you have square area. All right, so you can take anything. You can take a rectangle, measure one side, measure the other side, multiply them with each other, and that will give you the area, and it'll be in terms of whatever you used, squared. So square inches, square centimeters, square millimeters, square meters, it doesn't matter, all right? So if x equals 10, always like 10, so does the metric system. And so if the length of a line in one direction is 10, and the length of a square in the other direction is 10, then 10 squared is equal to 100. And see, we can see the square area is 100. Have I lost anybody? Well, let's take one more line and push it into the third dimension, and it is another line x. All right. And now we have this thing called a cube. I have one right here. Here's my cube. And now we have a cube. And if each side of the cube is x, then it would make sense that its volume is described as length times length times length, or length cubed. And so when we talk about volumes, we can either talk about a volume like a liter, or we can talk about a volume in terms of cubic centimeters, cubic length. And this is where this comes from, and that's why volumes like liters and things based on liters are immediately interchangeable with cubic lengths from the metric system. And so the volume of this cube is x cubed, and that's where all that cubic length business comes from when we talk about volumes. So again, if x is 10, then the volume of this box is 1,000. All right? Somebody's got their calculator to make sure that I'm doing the math correctly. Thank you. Hopefully they won't get their rulers out and find out the squares aren't cut exactly correct. I did the best I could. So volume is a cubed function of length. Hopefully everybody has an understanding of that. So we can take our 1 liter bottle of water and pour it into a cube that holds 1 liter. I'll give you a hint. Here's the cube right here. It's not really ready for you to pour water into. Here, you can take this if you want. I guess not. No, nobody wants my cube. So let's pour our 1 liter bottle into a 1 liter cube. And divide the cube into 1,000 cubes. And we will see that we have 1/1,000th of a liter, which is the same thing as 1 milliliter, which is the same thing as 1 cubic centimeter. And a cubic centimeter is either abbreviated cc or cm to the 3rd power. And so milliliter, cc, and cm to the 3rd power is all exactly the same thing. And we get a lot of that in this medical business, where one thing has a million different TLAs. TLAs are 3-letter abbreviations, unless there's only 2 letters involved, and then those are 2-letter abbreviations. And sometimes it means 4-letter abbreviations, too. So 1 milliliter, 1 cubic centimeter, or 1 centimeter cubed of water weighs 1 gram. And this is what the whole metric system is based on. So if we take 1,000 grams, we have a kilogram, and we're back to our original 1 liter of water, which is 1,000 milliliters, which is where we started from. Go figure. And so that's my best attempt to describe the metric system.
This is the University of Hawaii Maui College, the college on Maui.